Our next section is going to be talking about logarithmic functions. So if you remember where we kind of left off in the last section, we were going over what made something exponential and what those exponential graphs looked like. And we talked about the transformations of exponentials and kind of how they can move around on the graph and that can affect their asymptote, okay? And then we ended with talking about compounding either periods or compounding continuously. And so this next section is going to relate to what we've talked about in section 1 with the exponentials, but we're also going to kind of switch it now into talking about logarithmic functions. So being able to have something that's in an exponential form and have it look like something that's in a logarithmic form, or even going the other direction with that, is kind of what we're going to focus on today. So we're going to spend some time going over in this section some different properties that we can use to help us when we're trying to maybe evaluate a logarithmic function. And then we'll also talk about the graph and how it looks really similar to what we've talked about in the past with our exponential graphs, okay? So the first thing I want to be able to go over is how we can go back and forth between logarithmic form and exponential form. So when you have something written as a logarithmic equation or function, it's going to have this log piece in it, okay? Log is just short for logarithm. And so we can switch something that's written in log form to exponential form. So you might have something that starts out like this, where it says y equals log with this little b down here in the subscript area and then x. This is considered a logarithmic equation, okay? Now, when we move things around and we get rid of that log, so you can see how the little b here becomes the capital B, and it's, or not capital B, but a bigger B. It's not in the subscript area anymore. The y becomes an exponent next to the B, and then the x is now on the other side of the equal sign. That is just considered to be an exponential equation, and that's what we spent time with in the last section working on, okay? So kind of being able to go back and forth is like our first thing to be able to do. So for example, if I have something that says 3 equals log base 7x, and I wanted to rewrite that in exponential form, this 7 would come out first, and you would raise it to the number in front of the equal sign, which was that 3, and then it would say equals x. Now, if I actually wanted to solve this, which we'll get into in a little bit, actually being able to simplify these expressions, then we would do that as our next step, okay? But for right now, I just want us to be able to go kind of back and forth. Now, if you look at the next one, it's very similar here. They just kind of flipped the order on you. They switched, instead of the y equals being in the front, they put it at the end there. They say log with a base of b this time, 25 equals 2. So in this case, the little b is going to come out first. And what power are we going to raise that to? The squared, okay, because the 2. And then it would be equal to what? Yeah, 25. So b squared would be equal to 25. Why don't you guys go ahead and write down the next one? Okay, tell me what you guys wrote. Very good. 4 to the y power equals 26. So you can kind of see all three of those look a little different, either with how the form was given to you or maybe even how we kind of rearranged things. Some of the pieces kind of shifted or changed a little bit there. So it's totally fine, depending on what they give you, that you can kind of go from this logarithmic form to the exponential form, okay? However, we might need to go the other way. All right, we might have something in exponential form, but we want to write it in logarithmic form. And so that's what we're going to do next. We're going to go the other direction. So they're giving you a new couple of examples. All of these are written in exponential form, and we want to write them in logarithmic form. Okay, so for all of these, we need to have a log. And then remember, even if you need to use up the examples up above just to kind of help guide you along here, the little number that sits next to the log is the number that has the exponent. So in this case, I keep saying capital, but what I mean is like the large 2 that's raised to the 5th power, that little 2 is going to come down here next to the log. The x is going to come next because whatever was after the equal sign comes right after that log. So x comes here, and then the 5 ends it. Okay, so we're just going the other direction now. Go ahead and take a minute, and you guys write down what you think the next two should look like. Okay, how did you rewrite this next one? Good, perfect. How about the last one? Very good. Okay, we kind of get in the hang of how to go back and forth there. All right, let's go ahead and turn our page here. So remember what I said on those beginning ones is that sometimes you'll rewrite something in exponential form or maybe even in logarithmic form, but they might want you to take it a step further and actually solve it. Okay, and that's what we're going to start to do next. So in this case, you might be given something that looks like this first one where it says log with a base 10, 100. There is no equal sign here, okay? But we would want to maybe put in an equal sign so that we could actually solve an equation. So they're saying the first thing to do would be to set it equal to x. So that basically means up here they're adding on this to make it an equation. So it looks like log 10, 100 equals x. Then what they did in order to solve it is they took the log form and they rewrote it back into the exponential form. So they rewrote it with the 10 raised to the x power equals 100. Now, some of you are already going to know 10 to something is 100, okay? Some of you are going to be able to do that just mentally. But, if you're working with bigger numbers that maybe you're not quite sure, you don't know how to get there, what they're showing you do is you take the number on the other side of the equal sign. So in this case, the 100, and you would rewrite that so that it has a like base that's on the left side of the equal sign. And then the exponent is going to kind of help us figure out what our answer is. So they rewrote 100 as 10 squared. And so then if you look here, the x and the 2 are in the same position in our problem. And so that's how we know that x would be equal to 2. Like I said, though, some of you already know that 10 squared is 100, but maybe you're dealing with something that's like 2 to the 7th power. And that's maybe given to you as like a large number over here, but maybe you just don't recognize it. So you might have to do a little bit of like working backwards to actually figure out how much that thing is. Okay. All right, so let's do this next one here. We've got log 5 equals 1 over 125. So the first thing I need to do is put on equals x to make it that equation. And now I'm going to rewrite this. So the 5 comes out, x becomes the exponent, and then this is equal to 1 over 125. Okay, this looks a little different than the last one did. When we have a fraction in a problem, that if you're trying to get it to relate to the first half, that means that we're going to have to change the left-hand side a little bit to make it a fraction as well. So what I would do is on the left-hand side, I'm going to put 5 to the x power on the bottom. But when I do that, when I move it from the numerator to the denominator, it's going to impact the sign of that exponent. So I need to change it to a negative x. We've talked about this in the past when we were working with exponent rules. And when you had a negative exponent, you had to move it to the denominator. In this case, though, I started with a positive exponent. I'm moving it to the denominator, so it's going to cause it to become negative. Okay, now there's a 1 up here on the top now, and then this is equal to 1 over 125 yet. All right, so I'm getting them to be closer as far as how they look with each other. Now I want to think about, can I raise 5 to a power and get 125? And again, if you don't know, you can always use a calculator to assist you here. You can just start taking 5 and raise it to different powers, squared, 3, 4, whatever, to see which one works. Okay? So I want you guys to maybe do that and tell me, what power can we raise 5 to and get 125? To the third? Okay, so I'm going to rewrite this as 5 to the 3. Now, when you look at these, just like the last problem that we did, everything looks kind of matchy-matchy. We've got 1s on top, we got 5s on the bottom. But now if you look at what's left in the exponents, we've got a negative x and we've got a 3. So I'm going to kind of ignore everything else here. I'm going to focus on that. So if I had negative x equals 3, how would we fix this so that it makes more sense and we have a positive variable? Yeah, you just switch the sign. So it'd be x equals negative 3, and there would be your answer. So if you kind of backtrack with me here, back to the original problem that we rewrote it as, like, which is right here. If I take 5 to the negative 3, and you could even test this out on your calculator. If you take 5 to the negative 3 power, your calculator might give you a decimal, okay? And it might not be a very nice decimal, but you could always change it to a fraction, right? We all know how to do that. So if we change it to our fraction, it should say 1 over 125. Okay, so it does make sense when you're going back and forth between them. So it'd also be a really easy way to like check your work and see if you did it right, is by going back to your original equation, plug in that value that you solved for x, and see if it all makes sense with what you're calculating. Okay, why don't you guys take a couple minutes here and see what you can do with the next two. You should hopefully be able to do this next one okay. It might be that third one. It's a little different than what we've seen before, but just give it a try. See what you can do with it. All right, let's go through these two examples here. So let's start with this first one. If you guys set it up where you said equals to x, how did you rewrite it? Okay, sounds good. Now, what did you do from here? Remember, the goal is like you want to get like bases. So how do you make them both have like 6s as the base? Okay, so I'm going to write it like this. I agree with you that 6 squared would be 36 here. Now, the reason why I'm putting parentheses around that is just in case the exponent piece maybe had a little bit more to it. Like if it was a x plus 1 or an x minus 2 or something, I might want to separate those out with parentheses. Okay, now we have like bases. So we have 2 and an x here. I'm just going to stick those together because they're multiplying, so 2x. Now, what exponent does a regular standalone 6 have? Yeah, it has a 1, so I should be able to set it equal to 1 like that. What do you need to do here to solve for x then? Good, divide by 2, so you get x equals 1/2. Good. Okay, a little different than the ones that we saw before, but I still think manageable. Like you maybe should have been able to get a little ways through that, okay? Now let's take a look at this next one, because this one might have stumped a couple of you. We're going to set this equal to x again, and we're going to rewrite it. So it says 3 to the x power is equal to the 7th root of 3, okay? Now, the one side has a square root, the other side does not. We want to try to get them to look the same. So if you remember when we've talked in the past about square roots, we can rewrite this quantity as 3 to some power. So I'm going to leave this 3 to the x over here. Does anyone remember how do you rewrite something written as a square root so that it has an exponent? Do you remember how to do that? Okay, where did you get the 1 from? Okay, so the 3 has a 1 there, right? So the 1 goes on top and the 7, because that's the root number on the bottom, goes on the outside like that. Okay, so if you didn't remember how to do that, you might have gotten stuck on how do we get these to have the same base of 3. You have to be able to rewrite the square root so that it's using an exponent. You should be able to go back and forth between a square root and its rational exponent if you need to. So in this case, then, they both have bases of 3's, and you should be able to say x equals 1/7 and be done. All right, any questions right now on solving those equations? Okay, if you guys go on to the next page here, we're going to kind of get into some basic logarithmic properties here. So these would be properties that would be true for any situation. So like the number could be changing, but as long as they kind of fit one of these scenarios, you should be able to use this rule to help you easily and like quickly solve something. Okay. The first one is if your log, like the base number, so the number down in the subscript, and the number that follows the log, so in this case, they're using letter B and B. If those are the same number, then that's going to always equal 1. Okay, so an example, it might look like log 7, something like that. The answer is just going to be 1. Anytime that it has the same base and the same number that follows, it's always equal to 1. Now, if you have something that has log with a base, but it's immediately followed by a 1, the answer is always going to be 0. So it could be log 7, 1, that answer is always going to be 0. So no matter what the base number might be, if it's followed by a 1, the answer is always 0. The next couple kind of show that you have like a log with a base, and again, it kind of looks like that first property where it's followed immediately by the same number. But what they're trying to show you here is that basically on number 3, the log b and the b would cancel off, and you'd be left with just the exponent x. And so that would be your answer. And then the same thing happens down here. It's just you have the base b being raised to a logarithm. So again, like these quantities kind of cross off, and you're left with just the x again. So anytime you see something written like that, we should be able to just simply get to those types of answers. Okay. Now, you may not be able to go straight there. Like you might have to do a little bit of manipulating and rewriting some things, maybe in order to make it look like one of these properties. And so if we need to do that first, we will. Okay. So let's take a look at some examples here together. So if we look down here at this first kind of chunk, there's like 6 here that we're going to do together, and then I'll give you guys some time to like practice on your own. Let's start with the ones that should be fairly easy because they kind of match those properties up above. So starting with the ones here on the left column, this first one that says log 5, what's the answer going to be? Yeah, it looks just like the first property, so it should just be 1. Okay. The next one, log 15, 1, that should be equal to, good, 0. That looks just like the second one we talked about. Okay, and then the third one here, log 11 followed by 11. Remember we talked about that up here on number 3. Those cancel off, and you're left with just the exponent, which is a 10. Okay, now if you kind of skip over here to the right side, just go directly to the right. This bottom one is just like number 4. The 4 log 4 is going to cancel off, and you're going to be left with just the 7. Okay, so those 4 match those properties perfectly up above. Now these remaining 2, they don't look exactly like what we saw up above, so we need to rewrite this a little bit. So because they have this extra number sitting on the front here, what we're going to have to do is take the number that's sitting in the front, so in this case this 8, we're going to have to move it so it comes following after the exponent here. So what that means is really you're writing it like this: log 3 to the 8 power. So it's that 8 is being moved up into an exponent spot on the outside of the parenthesis. Now this looks like what we saw in number 3, because now we have log 3. These are going to cancel off, and we're going to be left with just 8. Okay, now we're going to do something similar with the next one. We're going to move the 124 into the exponent spot. Okay, so I'm going to write this over here. It says log 15, 1. All of this is now raised to the 124. Okay, but what did we say when it's written as a log and it has a 1 immediately following the log that the answer was? Yeah, it's always 0. Okay, so really this whole piece becomes like 0. Will 0 raise to any power, even if it is to the 124th power? It's going to just be 0. Okay, so your answer here is still just a 0. So if they throw in numbers like that, you might need to do a little bit of rewriting in order to simplify. So underneath this one, there are 6 more, very similar to what we just talked about. Go ahead and take a minute and do those 6. Okay, let's go through these here. Some of them should have been pretty easy, so let's start with those. So I want to know the answers. I'm just going to star the ones that I think should have been easy. This one, and this one. Those ones should have been pretty straightforward. So let's start up here. Log 2 is going to equal, good, 1. The next one, log 3 1 is 0. Okay, I'm skipping over that one. Let's go to this last one here. It should have just been what? Good, 3. Okay, the reason why I skipped over the third one in the first column is because you do have to do a little bit of rewriting here. And we didn't see one that looked like this up above. I don't have it looking exactly like where the 2 bases are the same, and we're able to just grab the exponent like we had up on our example. Could you, though, rewrite 8 as 2 to some power? 2 to what power is 8? 2 to the third. Okay, so now it looks like that property that we talked up above, because now these pieces are going to cancel off and you're left with, good, a 3. All right, now the other 2, those were similar to what we had up above. What'd you guys say the answer was to this one? Good, -5. And then how about this one? Very good, 0. Okay, do we have any questions on using those properties?